Okay, so come back, again, very similar. Given these 2 points, we should know what our initial value is, right?
Yeah.
What is it?
6.4.
Right, so our A equals 6.4. So once we have that, we can go Y equals, actually not even Y equals,
400 equals 6.4 times parentheses B parentheses to the power of 3.
okay? 6.4 times B to the third power. Can't you put B in parentheses? Absolutely. Okay. So then what did you do next?
Divide by 6.4. You get 15.625.
Okay, and again, there is a third root button if you go to your math button, but again, in your calculator, you can just type in 15.625 raised to the 1/3 power,
And you get 2.5.
and B equals 2.5, so our equation here, Y equals 6.4 times 2.5 to the X. Okay, so, make sense? More or less? Okay, next part, okay, compound interest. So, very similar to what we did yesterday. This part shouldn't be too terribly difficult. But compound interest, anybody know what compound interest is?
It keeps adding up over time.
Right, so like simple interest, like you just calculate your interest one time,
Yeah.
right? So, I mean, simple interest is handy because it's simple and it makes a little more sense, whereas compound interest, like every time, like you take interest on the first value, okay, and then the next time you calculate interest, you calculate it on that value with the interest that's already collected.
Mhm.
Right, and so it just keeps compounding upon itself, so you build interest on interest, kind of is how you look at it, okay? If you think about investments, stocks, stuff like that, that's where a lot of this stuff comes into play. So compound interest formula, A equals P times 1 plus R over N raised to the NT. So what does all these things mean? And, well, again, just like Y, this is gonna be our final amount, our A value. Okay, our P stands for,
Initial.
okay, principal, which is the initial value. I'll make sure I spell principal right. Okay, our R is obviously our what?
Is our
Okay, that's like our interest rate.
rate, yeah.
Our N,
It's the new.
it's the number of times your interest is compounded over the course of a year. Okay, so if it's compounded monthly, that'd be 12 times.
No,
Okay.
T is the amount of time.
Okay, and then T is time in years. Okay, so again, monthly would be 12, weekly 52, daily, daily 365, right? Okay, this one has quarterly.
For sure.
Okay, quarterly would be 4 times, right? If they said just it's compounded annually, once a year, all right? So, so this problem says our initial investment is $2,500. Our rate is 5% compounded quarterly. What is the value going to be in 5 years? So again, all we need to do here, plug and chug. A equals 2,500 times 1 plus 0.05 over 4 raised to the
4 times 5.
4 times 5. Now, you can type this in directly into your calculator. Okay, again, so this shouldn't be too much work. The only thing, when you type this in your calculator, parentheses are key. Alright, so 2,500 parenthesis 1 plus parenthesis 0.05 divided by 4, parenthesis, caret, and then I would just do that multiplication in your head, 20, 4 times 5 is 20. Then hit enter, and we get what? What'd you get?
3205.
3205. Was there a decimal with it?
Point one. Yeah, point one, it was 0.093.
Oh, 0.09. Okay, again, we're talking about money here, so we're gonna round to the hundred. Okay, so basically what this is saying is if you invested $2,500 that had an average, interest rate of 5% compounded quarterly over the course of 5 years, how much money did you just make in that investment?
$705.
$705. Okay, again, not a large amount really for your money just sitting there, but hey, no work, and you made $705. Alright, so.
That's a good, that's not a big interest rate.
Okay, so again, when you're talking about stocks, probably not looking, probably not wanting that type of return, because stocks is a little bit more volatile. Now again, if you're taking a retirement fund, stuff like that, again, think about this, now we're not looking at 5 years, we're looking at, 40 years down the road or whatever, so, like I said, that's, like I talked about yesterday, this is where exponential functions really come into play, alright? The last thing, it's no different than how we started today. The only change is if b to the x is greater than b to the y, then x is greater than y, then we're gonna go through and solve the equations the exact same. The only reminder is, okay, when we do that, well, I'll just do a quick one.
You really make that much money in 40 years.
Alright, so 25 to the x is greater than or equal to 1 over 125 raised to the 2x minus 1.
40 years.
Shut it. So, how are we gonna solve this?
We're just doing the same thing we just did,
Correct.
so we're trying to make them the same.
So we wanna make the base the same, so how are we gonna do that?
We're gonna times it by the negative first. Negative.
Okay, so I'll make this 25 to the x is greater than or equal to 125 to the negative 1. Okay, raised to the 2x minus 1. Okay, what next?
Now you're gonna have, you have to turn 25 like down by 2 to
So
get
this is
5.
gonna be like 5 squared.
You have, and then you have to take 125 down by 3 to get.
So this is gonna be like 5 to the negative third now.
Yep,
Is everybody good with that?
there was definitely a better way to do that, but
There is?
there was. But now we're here, so.
So 2x is greater than or equal to, again, I'm gonna distribute that. So negative 6x plus 3, yeah?
Yep.
Okay, I'm gonna do this backwards, just because I can. I'm gonna subtract this 2x over here. And then subtract the 3 over here, so I end up with negative 8x is less than or equal to negative 3. Now, the reason I did this is, because the next step is gonna be what?
Divide.
So we get x,
3x.
but what do we divide by?
Negative
Remember, with inequalities, if we divide by a negative, we gotta flip it, so we end up with x is greater than or equal to 3/8. Okay. So like I said, if you would've added the 6x, that's exactly what you would've got, x is greater than or equal to 3/8. I just wanna give you that reminder of flipping your inequality if you divide by 0. Alright, so your assignment, page 464. Nine through 31 odds.